Assalamu alaikum. Hi and welcome back again to our course Circuit Simulation using Simscape in Simulink environment. In this video, we'll learn about the active filter. Active low pass filter. In the last video, we had seen that by just using RC, we can design a low pass filter which is a passive and first order. But this kind of low pass filter have some limitation. The first one that the output is always less than the input, and the cutoff frequency depends on the load. If the load modified, the cutoff frequency should be modified also. To overcome this limitation, we just need to use another kind of filter, which is active filter, by adding an active component such as operational amplifier and transistor. This topology consists of two states. The first state is low pass filter, and the second one is an active component, which is operational amplifier. This filter pass low frequency to the input of this amplifier. So the amplifier has a specific feature, which is the input impedance is high and the output impedance is always low. And these characteristics, because of this characteristic, we can use this amplifier as a buffer to isolate the output. And by adding this operational amplifier, we can solve the first problem, which is the cutoff frequency depends on the load. By using this buffer, we can isolate the load from the circuit of the filter. So this configuration contains or consists of power, which the gain of this power is 1, which is unity. So the output is always equal to the input of this side of our circuit. Another topology, when we need to amplify the input, we need to add two resistors as this, like this. And the gain of this amplifier in this case is equal to 1 plus R2 over R1. And the value of the output is depend on this gain, which is pass band gain. And the output, we can get it from this equation. The out is equal to AF divided by 1 plus X squared multiplied by Vn. X is equal to frequency of the input signal over cutoff frequency. Cutoff frequency equation is like this, 1 over 2 pi RC. We have 3 cases. If the frequency of the input signal is less than the cutoff frequency, or is equal to the cutoff frequency, or is higher than the cutoff frequency, the gain of this circuit is equal to, or it is depend on AF multiplied by 1 or multiplied by 0.707 or greater than AF. AF is equal to 1 plus R2 over R1. This is mathematical. Let's see this in MATLAB Simulink. We are going to model this circuit. R is equal to 10 kilo, C R1, R2, and we are going to test this circuit with 3 cases, which is at the first case, frequency is equal to 50, and 2 is equal to cutoff frequency, and the third case, the frequency is equal to 500. We also we are going to use MATLAB code to calculate the value and compare them with the result from the simulation. Let's go to the Simulink. Here is our model. We have the signal with 50 Hertz and the frequency here, sorry, not frequency, I mean the capacitor, then 100, and the 2 resistor, and this resistor is equal to 1000. Okay, let's add a noise to this circuit. Okay, a noise with 1 amplitude and 1000 and 1000 hertz. Okay, I'm going to copy this circuit and repeat it 3 times to illustrate the 3 cases. The first case, the frequency is less than the cutoff frequency. The second one, the frequency is equal to the cutoff frequency, and the third one is the frequency is greater than the cutoff frequency. And I'm going to add just noise to our model to see if this circuit works or not. According to this component and the name of this circuit, the circuit should just allow the low frequency to pass. Okay, those are 3 cases. Here the frequency is 500, and here the noise. Here is the noise. An amplitude 1. Here the noise and amplitude 1. Yeah. This is our 3 cases. Let's run our model and see the results. Okay. Before we see the result, let us go back to our slide again and look at this code. In this code, this code can calculate the value of the output in 3 cases by changing the value of frequency in each case. Here, the first case, which is the value of frequency is 50, the frequency of the input signal is 50, the output is 9.5, which is very close to the AF. AF is gain, the gain is 10. And in the second case, the frequency is equal to cutoff frequency, the output or the gain is equal to 7.07, as here the output should be 0.07 multiplied by AF, and AF equal 10. And the third case, the frequency is equal to 500, and the output here is 3.0, which is very small, or very few, or very small amount of. It's not a frequency, it is a gain, sorry. It is a gain. Here is a very is smaller than the AF. AF is 10, here is a 3. So let's see our result now. It should be closer than this value, to this value. It should be closer to this value. What's going on? Yeah, here's our result. Case 1. The input is 5 and the output is about 50. Okay. Yeah, it's about 50. Let's go back to our slide. Which one? Not the output. Here is the output as general, and this value is the value of the gain. Sorry, again, this is gain. It means that V out over Vn. The Vin is equal to 5 and V out is about 50. when we divided V out by V in, that means about 50 by 5 is approximately 9.5. Let's see the second case, which is V in is 5 and V out, let us choose it, is about 39. When divide the V out by V in, we can get this number approximately. The last signal is V out 3, the V in is 5 and V out 3 is about 20. When we divide 20 by 5, we can get this value. That means that our circuit, it works. And this is the output of the low pass active filter. Thank you for watching. And if you have any question, don't hesitate, just ask. And if you find this lecture very helpful for you, just subscribe. And thank you.